Okay, so today we make the big connections from our plate to our special right triangles and back and forth. I'm going to start by quickly reviewing the 30, 60, 90, remembering that opposite 30 is our short side, we call it x. The hypotenuse is twice as long, so we call it 2x. And the middle side is the short side times the square root of 3, x root 3. So for an example, if I had a 30, 60, 90 right triangle in which I knew the middle side had a length of 5 root 3, then I can quickly know, without SOHCAHTOA, without a Pythagorean theorem, that the short side is 5 and the hypotenuse is twice that, which is 10. You need to know these rules. You should know them already. If you haven't learned them yet, now is the time. We're going to be applying them for the rest of the year. The isosceles right triangle, the 45, 45, 90, has two equal legs, so we call them x, and the hypotenuse then is the leg times root 2, x root 2. So again, for a quick example, if I have an isosceles right triangle and I know the hypotenuse is 7 root 2, then each leg has to be 7. Really quick math if you know those rules. So who cares? Well, on our plates we've labeled the 30, 45, and 60 degree angles. And we could draw right triangles around them. We won't because it really makes the plate messy. And that's why we talk about it on a separate piece of paper and transfer the big aha moment to the plate. So here on my paper I have a sketch of the unit circle, which remember means it has a radius of 1. Well, with my right triangle, the hypotenuse is the radius, so the hypotenuse has to measure 1. That's twice the short side, or the short side's half the hypotenuse. Half of 1 is 1/2. The middle side then is the short side 1/2 times the square root of 3. That's a little bit messy, so we decide to clean it up and call it root 3 over 2. Either answer is fine. I just prefer root 3 over 2 because it's neater. 1/2 root 3 though is okay. Well, also remember on our unit circle we start at the origin 0, 0. So if we think about this as a graph, we've gone over root 3 over 2 units, and we can transfer that to the triangle off the circle if it makes you feel better. That length is root 3 over 2. And we've gone up 1/2 of a unit. So think about plotting points. Sorry, when you go over root 3 over 2 and up 1/2, you land at the point root 3 over 2, 1/2. Just like if you went over 5 up 7, you'd land at the point 5, 7. Math is consistent. So I go over root 3 over 2, up 1/2, and the coordinate of that point at 30 degrees is root 3 over 2, 1/2. Put that on your plate. 30 degrees now has its third name. It's 30 degrees, it is pi/6 radians, and now we know its coordinate name is root 3 over 2, 1/2. 30 is finished. It has its three names. We'll learn how to use those names in a bit. Going back to your lab packet, let's do similar things with the 45 and 60 degree angle. So imagine we're on your plate at the 45 degree angle, and we drew a triangle around it. We won't on the plate, we'll do it on the paper. Again, it's a unit circle, the hypotenuse is 1. That means the length of each leg is half the hypotenuse times root 2, or 1/2 root 2. Again, that's a little messy, so I prefer to call it root 2 over 2. Either answer, either version is fine. Again, I just like the neater root 2 over 2. So you won't see me write or hear me say 1/2 root 2 again. I'll always call it root 2 over 2. Just like with our earlier triangle, we start at 0, 0, but this time I move over root 2 over 2 units and up root 2 over 2 units, which means the point I land on over root 2 over 2, up root 2 over 2 is root 2 over 2, root 2 over 2. Put that on your plate at 45 degrees, and now 45 degrees has its third name. 45 degrees, pi/4 radians, and now its coordinate name, you know, is root 2 over 2, root 2 over 2. We do the same thing with 60. first make sure the first two are okay. So again, with 60, the radius is 1, so the hypotenuse is 1, which means the short side opposite 30 is 1/2, and the medium side is √3/2, or 1/2 √3. Again, I'll always call it √3/2. When I start at 0, 0, and I move over 1/2 of a unit and up √3/2 units, I land at the point 1/2 √3/2. Label it on your paper, label it on your plate. Now 60 has its three names: 60 degrees, pi/3 radians, and the coordinate 1/2 √3/2. These three quadrant 1 points, as well as the 0, 90, 180, and 270, are key to everything we do with our plates. They are our parent points. Everything we get from here will come from 30, 45, and 60. Make sure you've got them labeled well. Okay, so now it's time to connect that information to TRIG. So here I have my three triangles again, thinking about them on the unit circle, labeling again one more time: hypotenuse 1. In a 30, the opposite side is 1/2, the middle is √3/2. And the question's asking for sine, cosine, and tangent of 30 degrees, so you need to remember SOHCAHTOA. Sine is opposite over hypotenuse. Go to 30, the side opposite is 1/2, over the hypotenuse is 1. 1/2 divided by 1 is 1/2. The sine of 30 degrees is 1/2. Cosine is adjacent over hypotenuse. The side adjacent 30 is √3/2. The hypotenuse is 1. √3/2 divided by 1 is √3/2. Cosine of 30 is √3/2. Tangent is opposite over adjacent. So the tangent of 30 is 1/2 over √3/2. This gets ugly. I'm going to show you the math once and ask you to memorize it after this. Rename it as division. 1/2 divided by √3/2. When we divide by fractions, we multiply by the reciprocal, so it's 1/2 times 2 over √3. We can't have radicals in the bottom of fractions, so we have to multiply both parts by √3, and in the end we get tan of 30 is √3/3. Memorize that. Tan 30, lots of 3's. That's my trick. Okay, back to the unit circle for the isosceles right triangle. My legs are √2/2. My hypotenuse is 1. If you want to pause and try this and then check, you can. I'll talk you through it now though. Sine again, opposite over hypotenuse. √2/2/1 is √2/2. Cosine adjacent over hypotenuse is √2/2/1, which is also √2/2. Tangent of 45 is opposite over adjacent. √2/2 divided by itself, √2/2, is 1. The tangent of 45 is 1. Do the same math with your 60. First label your right triangle from the unit circle. Hypotenuse is 1, opposite 60 is √3/2, short side's 1/2. Sine, opposite over hypotenuse. Sine of 60 is √3/2 over 1, which is just √3/2. Cosine is adjacent over hypotenuse. Cosine of 60 is 1/2 over 1, or just 1/2. Tangent is opposite over adjacent, which is √3/2 over 1/2. Again, this might be a memorizer for you as well, because the math's not a lot of fun. √3/2 divided by 1/2 is √3/2 times 2. 2's cancel, and we're left with √3. So I choose to memorize tan 30, √3/3, tan 60, √3, and just know the rest. Okay, so there are those values. The big question of the day is, where do you see those values on your plate? At 30 degrees, where do you see 1/2? At 30 degrees, where do you see √3/2? Same for 45 and 60. So take some time, pause the video, look at your plate, look at those values of sine and cosine of 30, 45, and 60, and make a connection. You'll remember it forever if you discover it. If I just sit here and tell you, you probably won't. So pause if you need to, rewind to the last frame if you need to see those values if you didn't get them all down. But look at your plate and try to make that connection. Well, here it is. At 30 degrees, the sine of 30 is 1/2. That's the y value. Sine of 45, root 2 over 2. Sine of 60, root 3 over 2. Every y value represents the sine of the angle. Similarly, cosine of 30, root 3 over 2. Cosine of 45, root 2 over 2. Cosine of 60, 1/2. Every x value on your unit circle represents cosine. That is the huge idea, the main idea of the day. All along your unit circle, your x value of your coordinate is cosine, your y value of your coordinate is sine. And then if you think about the math we did for tangent, we took every y and divided it by x, or we took every sine and divided it by cosine. So tangent is y over x, or sine over cosine. Make sure right now that your values are all correct, because I can go back now and say, hey, what's the sine of 30? You go to 30 degrees, look at the y value, and grab 1/2. I could say, hey, what's the cosine of pi fourths? You go to 45 degrees, because that's pi fourths radians, look at the x value, and you now know it's root 2 over 2. And we can talk about 90 and 180 and 270 now. We can go beyond a right triangle because of this basic knowledge. What about the children then in 2, 3, and 4? We haven't talked about them. We've ignored them. Well, the really good news is that on the first day with your plate, I had you label the signs of the coordinates in each quadrant. So let's start with our 30-degree family, our pi 6 family, and think about it. If I take any point in quadrant 1, like root 3 over 2 1/2, and reflect it into quadrant 2, the numbers stay the same, but the signs change. X becomes negative, y stays positive. So at 150 degrees, the coordinate name is negative root 3 over 2, positive 1/2. Every point in quadrant 3 is negative, x and y. So we have the same numbers, root 3 over 2 and 1/2, but they're both negative. At 210 degrees, my coordinate is negative root 3 over 2, negative 1/2. Likewise for 330, every point is positive x, negative y in quadrant 4. So at 330, the point is positive root 3 over 2, negative 1/2. The values never change, just the positive and negative signs. So math is consistent, same thing with 45. Root 2 over 2, root 2 over 2, reflected into quadrant 2, x goes negative, y stays positive. In quadrant 3, both x and y are negative. Your values are still root 2 over 2 and root 2 over 2, but in quadrant 3 they're both negative. And in quadrant 4, x stays positive and y goes negative. So the coordinate name at 315 in the pi fourths family, 7 pi over 4 radians, is positive root 2 over 2, negative root 2 over 2. So now I can ask you for sine and cosine of any of those values. And we end with our 60 degree or pi thirds family. Math again is consistent, so every coordinate will have the name 1/2 root 3 over 2 if it's a child of 60, but I just need to adjust the signs accordingly. In quadrant 2, x is negative and y is positive. So at 120 degrees, the coordinate is negative 1/2, positive root 3 over 2. At 240 degrees in quadrant 3, both x and y are negative. So the coordinate's negative 1/2, negative root 3 over 2. And in quadrant 4, x is positive and y is negative. So the coordinate at 300 degrees, the child of 60, is positive 1/2, negative root 3 over 2.